Lysogeny broth, a nutritionally rich medium, is primarily used for the growth of bacteria. The initialism is also commonly, albeit incorrectly, taken to mean Luria broth, Lennox broth, or Luria-Bertani medium. According to its creator Giuseppe Bertani, the abbreviation LB was actually intended to stand for Lysogeny broth. The formula of the LB medium was published in 1951 in the first paper of Bertani on lysogeny. In this article he described the modified single-burst experiment and the isolation of the phages P1, P2, and P3. He had developed the LB medium to optimize Shigella growth and plaque formation. LB media formulations have been an industry standard for the cultivation of Escherichia coli as far back as the 1950s. These media have been widely used in molecular microbiology applications for the preparation of plasmid DNA and recombinant proteins. It continues to be one of the most common media used for maintaining and cultivating laboratory recombinant strains of Escherichia coli. For physiological studies, however, the use of LB medium is to be discouraged. There are several common formulations of LB. Although they are different, they generally share a somewhat similar composition of ingredients used to promote growth, including the following: peptides and casein tones, vitamins, trace elements, minerals, peptides and tones are provided by tryptone. Vitamins and certain trace elements are provided by yeast extract. Sodium ions for transport and osmotic balance are provided by sodium chloride. Tryptone is used to provide essential amino acids to the growing bacteria, while the yeast extract is used to provide a plethora of organic compounds helpful for bacterial growth. In his original 1951 paper, Bertani used 10 grams of NaCl and 1 gram of glucose per 1 L of solution. Luria in his L broth of 1957 copied Bertani's original recipe exactly. Recipes published later have typically left out the glucose. Formulae: the formulations generally differ in the amount of sodium chloride, thus providing selection of the appropriate osmotic conditions for the particular bacterial strain and desired culture conditions. The low-salt formulations, Lennox and Luria, are ideal for cultures requiring salt-sensitive antibiotics. LB Miller, LB Lennox, LB Luria. Preparation. The following is a common method for the preparation of 1 liter of LB. Measure out the following: 10 g tryptone, 5 g yeast extract, 10 g NaCl. Suspend the solids in 800 milliliters of distilled or deionized water. Add further distilled water or deionized water, in a measuring cylinder to ensure accuracy, to make a total of 1 liter. Autoclave at 121 degrees Celsius for 20 minutes. After cooling, swirl the flask to ensure mixing, and the LB is ready for use. Adjusting the pH equals, prior to autoclaving, some labs adjust the pH of LB to 7.5 or 8 with sodium hydroxide. However, sodium hydroxide does not provide any buffering capacity to the media, and this results in rapid changes to the pH during bacteria cultivation. To get around this, some labs prefer to adjust the pH with 5 to 10 ml TRIS buffer, diluted from 1 mol per liter TRIS stock at the desired pH. However, it is not absolutely necessary to adjust the pH for most situations. Some labs adjust the pH to 7.0 merely as a precaution. Since the buffering with tris will also be largely ineffective in the face of substantial bacterial growth, adjusting the pH of LB in this particular manner is usually unnecessary. As such, use of tris in some broth recipes may be considered a superstitious procedure without much scientific merit. See also, agar plate, Salvador Luria, SOC medium. Another widely used medium for culture of Escherichia coli in molecular biology work. References